Okay, here we go. Let's talk about the last topic of this course. So today we're going to talk about power series solution. Okay, power series solution. Right? What is it? How do we attack it? And probably a little bit of why we care. Right? So let's jump right into it. Right? So what do we want to do here? Okay. So what we want to do is um, we want to understand first what is power series. Okay, so let me read it to you. Solving differential equation using power series. Okay, so power series, like what is it first? So it's a way to represent a function using the most simple function you can think of, which is a bunch of x to the n, like x squared, x3, x4, so on and so forth, right? You're just gonna use those x to the some power to represent all the function that we want. Right? So for example, fx equal to e to the x. Right? So the name of the game is we represent e to the x using a bunch of x to the n. Okay, so what do we mean by this? Let's look at the example, okay? So this is what something you learn in Math 1 with Ajahn Pong San, okay? That e to the x can be represented as power series using this, okay? 1 plus x plus 1 over 2 factorial x squared, 3 factorial x3, 4 factorial x4, so on and so forth, right? So this is sometimes called Taylor series, or even better, Maclaurin series, right? So if you want to review, you can go back to review about power series, Maclaurin series, and Taylor series, right? Today we're not going to talk much about that, right? We're just going to focus on how do we find it, okay? So that's what kind of like what we want to do. Instead of writing e to the x, we're going to write answer as something like this. Now, you might wonder why. Why? E to the x looks so nice, right? Why do we have to like make our life hard and do this? And the answer is, this is actually a lot easier in a lot of sense, right? Let's imagine you have only like a calculator that can add and multiply, right? This is a good way to approximate e to the x, right? Right? If you have just like stupid calculator and you want to compute, right, e square, right? So e to the 2, right? Your calculator will be confused, like what is e to the 2, right? But this one you can do. You can just plug in 2 here, and then you get pretty darn good approximation of e to the 2, right? So this is for practicality for when you use differential equation in real life, right? You will get power series as a solution and it will be easy to use, right? And right here, I want to like take a step and kind of show you some graph that show that like power series actually not a bad idea, which is here. Okay, so let's see this graph. Okay, let's see this graph. What is this, right? So this graph is simply e to the x, right? As you show here, right? And I can show you that like, okay, let's say that I have a power series that I just take the first two terms, 1 plus x. Well, it just look like this, right? So is the blue graph good approximation of the red graph? I bet some of you would say, not really, right? Because it's kind of far away from each other. But let's look at this. If we adding terms, keep adding term, this, I add the square term, right? The blue become the green. If I add the third term, become the purple. And if I add the fourth term, it become the black, right? And look at how close they are, right? Look at how close they are, right? I know they are not the same, right? The red and the blue are not the same. But let's say that you have no way to calculate the red. The black will be a pretty good approximation still, right? So what we're gonna learn today is we're gonna learn the way to get solution in this kind of form, in the power series form, right? It will not be a real solution. It will be pretty darn good approximation, right? And the good thing is we can do that to almost any differential equation, right? Back then, when we learn about differential equation, we always say, oh, this equation is too hard. We don't know how to do. This equation is too hard. Let's make it easier. This one, you almost always say, oh, we can do it, okay? So let's see how we attack this kind of problem, right? So another example is 1 over 1 minus x give you differential equation that look like this. They'll give you power series that look like this. 1 plus x squared, x3, x4, so on and so forth. Right? So this is what we want to do, okay? We want to solve differential equation, and then we want the answer in this form, right? Something x, something x squared, something x3, something x4. So that looks scary, right? But this is kind of like the same pattern all the time. So instead of asking what is a power series, we kind of the same thing as asking, let's find A1, A2, A3, A4, or so on and so forth, right? And the key to be successful here is we're gonna use the method of comparing coefficients, right? What is it? We will see in the example, okay? All right. So let's look at the first example, okay? Solve differential equation y prime equal to xy, okay? So this one is actually separable, right? You can move y to the other side, integrate to get ln y equal to 1/2 x squared, and the answer will be e to the power of 1/2 x squared with the constant on top, but doesn't matter. We're gonna use power series to do this. Okay, how do we do this? And the question always like this. Okay, look at this. Power series kind of go on forever. Right? We always ask like, find the first 5 terms. Okay, and let's see what happened. Okay, so let's look at this. Okay, this is the way that we always want to do this, right? We want to find y first. Y equal to something, right? So the first line is our answer. Y equal to a0 plus a1 plus a2 x squared, and so on and so forth. And then the way we're gonna do is we're gonna find each of the term in here, right? So you look from the equation, you see, oh, we want to know y prime too, right? We want to know y prime. Here's the deal. Y prime and also everything else in the differential equation will be represented using power series too, right? So let's see this. Okay, let's see the second line. Okay, let me cover the third line up first. What does it say to the second line? The second line say, oh, if you know that y look like this, then y prime is nothing. You just differentiate the top line. A0 becomes 0, right? Because that's a constant. A1x, x become 1, so that's good. A2x squared become 2x, so that's good. And then imagine next term going to be A3x3, x3 become 3x2 with the A3, so on and so forth like this. Right, and then you keep doing. Make sure you get the first 5 terms, okay? Because you're gonna do the first 5 terms. Right? So xy is what? Xy, you look at the first equation and like, okay, that's y. Right? You multiply by x means you multiply every term by x. So that's easy. A0 become A0x. A1x become A1x squared. A2x squared become A2x cubed. So on and so forth. Alright, so that's kind of like a preparation state, right? You kind of prepare everything together. And now you would add everything together, right? Or you compare everything together. So let's see what happened next. Right? What you want to do is, you see, the equation say y prime equal to xy, right? So what should happen is the thing in front of x should be the same as the thing in front of x. The constant term should be the same as constant term, so on and so forth, yada. Okay? So let's look at the constant term first because that's the easiest one, right? The constant term is the one without x. So it's this guy, right? This is the one without x. How about the one without x here? Nothing, right? So the first equation that we get is simple. Is a1 has to be 0, right? Because a1 plus 0 has to be 0, so a1 is 0. Alright, and then we keep doing the same thing over and over, okay? So let's look at the green term. What's special about the green term is they are the thing that label with just x. Not constant, not x squared, not x cubed. This is something x. So this is something x, this is something x. So they are the same, so you're gonna have 2a2 equal to a0 because 2a2 is a thing in front of x in the first equation. First term, a0 is the thing in front of x in the second term, right? And that's why you have this. Let's look at the left hand side first, don't look at the right yet, okay? X squared equal to this guy, right? So we have this equal to this. So a1, which is this, equal to 3a3, which is this. Alright, and then you keep doing until the end of time. Alright, in fact, a5 you don't need to do because we're gonna find first 4 terms. Okay, so we're gonna find a0, a1, a2, a3. So we don't have to worry about a5 actually. Right? Okay, so what do we do here? Then we try to find relationship between the term, right? So a1 equal to 0. So good, a1 equal to 0. How about a0? a0 never get mentioned. So a0 actually can be anything, right? What do you mean by anything, right? There must be a solution. Well, I hope like after 15 weeks, you learn that differential equation can have infinitely many solutions, right? So that's where infinite solution come from. A0 can be literally anything, right? And then you get 2a2 equal to a0, 3a3 equal to a1, and after that, things gonna be compared to the term before. For example, you know a1 equal to 0 because of this equation, and you know a2 equal to a0 over 2 because of this equation. So what's gonna happen here is that you let a0 be anything. Now a2 gonna follow the rule from a0. a3 equal to 3a3 equal to a1, but a1 is 0, so you know a3 is 0. a4 become a2 over 4, right? Because of this. But then a2 is a0 over 2, right? So we can combine this, that like a4 is a0 over 2, but a4 is a2 over 4, but you put a0 over 2 instead of a2, so you get a 0 over 8. I hope that does not confuse you, right? And then a5 becomes 0, right? So what solution here will go like this? a0 plus a1x plus a2x squared plus a3x cubed plus a4, so on and so forth. Now you substitute the result in, right? And here's the thing. The first order differential equation should have only one constant, right? Like remember when you have y prime, you do something, you get c. Alright, if you do y double prime, you can have c1, c2. If you do y triple prime, you get c1, c2, c3. Right? So the number of constants you have will depend on the order of differential equation. Right? Now you have order 1, so you can have only one constant. So everything should be rewritten as a0. Right? And in this case, you can, right? You have a0, a1 is 0, a2 is a0 over 2, and a4, sorry, is a0 over 8. Right? So that's the first 5 term. And at the end of the day, you can write your answer like this. Y is just a0 times 1, which is from here, 1/2, which is from here, and then 1/8, which is from here. And then you're done. Alright, so that's the concept, okay? So you write out y equal to the form that you have, and then you try to get everything in your differential equation out, and then compare them according to the equation, and compare the coefficient one by one. Alright, so let's talk about like we can find all an, right? But usually we're gonna find the first few terms. So for first 5 terms, we'll go from a0 to a4. If I'm mean, I can ask you for the first 10 terms, we'll go up to a9, right? So we don't have to find general form. Alright, let's look at one more example. It's gonna be y double prime xy prime plus y, right? And we're gonna find first 5 terms of the solution. So what do we do? First thing to remember is that when you have second order differential equation, you have 2 constants, right? Now you allow to have like a0 and a1. So let's see what happened first. Okay, so you start off with y equal to this guy, right? And you want to find all the term here. Sorry. You want to find all the term here, right? So let's start off with xy prime. Well, if you do xy prime right away, it might be confusing. So let's do y prime first. I cross it out because we're not going to use it eventually, right? But you can see that like 0 come from differentiating this guy, a1 come from this guy, a2 become 2, x squared become 2x, so we have 2a2x, so on and so forth, right? And if you will, make sure you go until like a4, because a4 is the thing that like we want first phi term, right? You should do all the way to a4. All right, so when we have y prime, what do we do here? Well, we will find x y prime, and this step is easy, right? Because you just multiply everything by x, right? 0 still be 0, a1 become a1x, a2x become a2x squared, and this become this, okay? And then y double prime, right? Because that's the other term that you want to find, y double prime. So what do we do? Well, we take y prime and then we differentiate again. So not only a0 becomes 0, now a1 become a1 and then become 0 too, right? So the rest of the term you just differentiate, so on and so forth, okay? All right, and then what do we do? All right, and what we do here is we write down this differential equation and make sure you kind of combine the coefficient together, okay? So y double prime plus xy prime plus y equal to this, okay? So let's combine the same order together. So constant you combine here, the x you combine here, and the square you combine here, right? And there's no need to go to the third term, because the third term will have a5, which we don't care. This is the highest we go, okay? So let's look at each term carefully, okay? The constant, you just look at the 3 equations that you have, the 3 terms that you combine, and see what constant you have. You have constant here, right? That's why you get here, right? For the x, you see that there's x here, there's x here, there's x here, right? So you combine a1 to 6a3, and that's why you get a1 plus 6a3, and the same thing here. You compare it to the right hand side. The right hand side is what? The right hand side now is 0, right? Let's go back to differential equation. You see that the right hand side now is 0, right? And therefore you get 0 like this, right? And the way you to realize it's 0 is every coefficient is 0. So this is 0, this is 0, this is 0, and that gives us 3 differential system of equation. System of 3 equation. All right, and which can be rewritten like this, okay? This might look scary, right? But this is nothing, okay? This is just you set the first guy equal to 0, you set the second guy equal to 0, and you get the third guy equal to 0, right? And then what you do after this is you go one by one. You go one by one and ask ourselves, what is the condition on that guy, right? Right? Remember, this is differential equation of order 2, so we allow to have 2 constants. Actually, in general, you can pick the constant that you like, but in this case, we're gonna let it be a0 and a1, right? In terms of a0 and a1, right? So a0 and a1 can be anything, so we start off with the first equation and figure out a2, right? a0 is 2a2, so a2 is 1/2 a0 with a minus sign, and since a0 is the thing we want, so we good, right? We allow a0 to be there, so this equation is good. All right, let's look at second equation, right? Second equation is a1 plus 6a3 is 0, so a3 is minus 1/3 a1, and a1 is a thing that in our list, so we're good, right? The last equation is a little tricky though, right? So let's take a look. Is a2 plus 2a2 plus 12a4 equal to 0. So in general, you would think that the answer is, oh, a4 is equal to minus 1/4 a2. But remember, a2 is not variable that we allow, right? a2 is not among a1 and a0. So we cannot use this, right? We cannot have 3 constants, a0, a1, a2, right? So what do we do? Well, we know that a2 equals to something in terms of a0, right? So we can sub this guy in here, and we get 1/8 a0, right? This is the same thing that happened to the previous equation too, but I didn't explain it clearly, right? And the answer is kind of like this, right? This is the general form, and then you sub in the form that you have, right? a1x a0, that is fine because second order differential equation can have 2 constants. Um, A2 is minus 1/2 A0, A3 is minus 1/3 A1, and A4 is plus 1/8 A0. All right, writing in a nicer form, you can combine A0 and A1 together, but we don't have to. All right, so there's one more problem that um, I'll talk to you briefly, but I'll let you read it mostly by yourself, okay? Because it's the same thing as before. But basically, we can do this with differential equation too. All right, so what we can do this with initial value problem too. So let's look at this and ask ourselves, okay, what happens if we add this condition, right? Y0 equal to 1 and y prime 0 equal to 4, right? With this, it's not hard, right? We just ask what is A0 and what is A1 and you plug in. Look at this guy, right? If you have solution being A0 plus A1x plus A2x squared and so on and so forth, Y0 would just be A0 and Y prime 0 would just be A1, right? Imagine you plug in 0, everything here is gone. If you plug in Y prime equal to 0, plug in 0 equal to Y prime, this will be gone because of differentiation. This will become 1. This will become 2x and this will become 3x squared, so on and so forth. When you plug in 0, this will be gone and you left with A1. Right? With all of this combined, all you need to know is that if the problem tell you y0 equal to 1 and y prime equal to 4, it tell you a0 and a1. So what you do is you just solve differential equation the normal way you do, right? And then you just plug in a0 equal to the y0 and then a1 by y prime 0. Okay, so let's look at the same differential equation but with y0 and y1, right? So this is pretty simple, right? We did this problem before, right? And the answer is this guy, right? But now we have initial condition. So initial condition will turn infinitely many solution to just one solution. But we know that this is just A0. This is just A1. So just plug in A0 and A1 accordingly. And you will have something like this. Okay, last problem. I'll let you mostly read it by yourself, okay? So differential equation look like this, right? So what you want to do is you want to expand the right hand side and then you compare left hand side and compare to the right hand side. Okay, I will post the notes in the classroom, but you will see that the method are the same. You expand everything, you compare, and then you have the answer, right? So let me go through this really quickly, okay? So what do we do here, right? X squared plus 1 y double prime, xy prime minus y, right? So first of all, I'm gonna expand x squared plus 1 y double prime as x squared y double prime and y double prime, right? And then you find the fourth term. X squared y double prime is right here. Y double prime is right here. Xy prime right here. And then y with the minus sign is right here, right? Don't forget the minus sign here, right? You combine, you expand everything and combine everything according to the power, right? For example, x squared, you combine x squared together, you get this, right? The x you combine together, you get this, right? The tricky part is you compare to the right hand side, which is not 0 now, right? Now is 1 plus 2x minus x squared, right? So to make it nicer, compare this to this, right? 1 minus 2x squared, right? The key is we compare the coefficient, mean the thing in front of the x should be the same, the thing in front of x squared should be the same, and the thing is a constant term, it should be the same, right? So in other words, these are the same, these are the same, and these are the same, and that gives us three system of three equations, right? And then you do the same process, okay? You will get everything in terms of A1, everything in terms of A0 and A1 in this case, right? Yeah, so A1 is kind of like by itself, everything in terms of A0 or A1 being in terms of A1. So you can read through a note and you see that this is a solution. But with initial condition, you can replace A0 by minus 1 and A2 by 2, a1 by 2, and then you get this as your answer. And that's how you get the first 5 term of the solution.